गुड इवनिंग सभी को। नमस्कार। स्वागत है आपका हमारे इस प्लेटफॉर्म पे जिसका नाम है वन मार्क सोल्यूशन। और आज न्यू ईयर है तो सभी को बेस्ट विशेस, सभी को हैप्पी न्यू ईयर सभी को। और नववर्ष की हार्दिक शुभकामनाएं हमारी वन मार्क टीम की तरफ से सभी व्यूवर्स को। और जैसा कि आप सभी जानते हैं कि हमारे इस प्लेटफॉर्म पे जो वन मार्क्स के क्वेश्चन होते हैं उनको यहाँ पे डिस्कस किया जाता है। डिफरेंट सब्जेक्ट के डिफरेंट चैप्टर्स के जो वन मार्क्स के क्वेश्चंस होते हैं जिनको सीबीएसई ने अभी इंट्रोड्यूस किया है। असर्शन रीजंस के जो क्वेश्चन होते हैं, मैथ्स दी फॉलोइंग क्वेश्चन होते हैं। यहाँ पे जो सब्जेक्ट एक्सपर्ट आते हैं वो आपको फुल एक्सप्लेनेशन के साथ, एक एक क्वेश्चन के एक्सप्लेनेशन के साथ आपको आंसर कैसे देना है, हमें वन मार्क्स के ऑब्जेक्टिव टाइप के आंसर कैसे, क्वेश्चन को कैसे अटेम्प्ट करना है, ये आपको बताते हैं। तो हम लोग 3-4 महीने से लगातार इस प्लेटफॉर्म पे हम लोग सेशन कंडक्ट करते आ रहे हैं। और 9th क्लास के लिए भी बहुत सारे चैप्टर्स के, साइंस चैप्टर्स के सेशंस हो चुके हैं। आज जो सेशन होने वाला है वो क्लास 9th साइंस के लिए होने वाला है। 31 दिसंबर को भी हमारा एक सेशन हुआ था क्लास 9th के लिए, इस मैटर अराउंड द स्पेयर। तो अगर जो भी हमारे व्यूवर्स हैं जिन्होंने नहीं वो देखा था तो हमारे चैनल को सब्सक्राइब करके आप प्ले लिस्ट में जाके वो देख सकते हैं सेशन। आज जो सेशन होने वाला है उसका नेक्स्ट चैप्टर है एटम्स और मॉलिक्यूल्स। और जिसके लिए आज मैं प्लेटफॉर्म पे मैम का स्वागत करती हूँ। मैम मोस्ट वेलकम आपका हमारी वन मार्क टीम की तरफ से, हमारे व्यूवर्स की तरफ से आपका मोस्ट वेलकम। और मैम का नाम है मरियम फातिमा मैम, और मैम पीटीटी साइंस हैं, केंद्रीय विद्यालय मानपुर, मुंबई महाराष्ट्र में। मैम ने इससे पहले भी यहाँ पे सेशन कंडक्ट किए हुए हैं आप लोग के जो भी चैप्टर साइंस से रिलेटेड। और आज मैम सेशन कंडक्ट करने वाली हैं, तो आप उसको थ्रू आउट देखते रहिए, लगातार उसमें बने रहिए लास्ट तक। और लास्ट में मैं लाइव कमेंट बॉक्स में एक फीडबैक फॉर्म शेयर करूँगी। पर आप उसको फिल करते हैं, 40% मार्क्स उसमें क्वालिफाई करते हैं, देन आपको अटेंडेंस सर्टिफिकेट भी आपके मेल आईडी पे इशू होगा। तो आप मेल आईडी करेक्ट डालेंगे तो आपके मेल आईडी पे करेक्ट सर्टिफिकेट आपके इशू होगा। और चैनल को सब्सक्राइब कर दीजिए क्योंकि अभी आपकी बोर्ड एग्जाम्स की भी डेट शीट आ गई है, 9th के भी एग्जाम्स की डेट शीट आ जाएगी, तो आप लोग के पास काफ़ी टाइम है तैयारी करने का। तो हमारे इस प्लेटफॉर्म पे हमारी यही कोशिश है कि हम लोग जो आपके वन मार्क्स के जो क्वेश्चन आपके आ रहे हैं वो आपकी गलत ना हो, और आप जो यहाँ पे कंटेंट इस प्लेटफॉर्म पे दिया जाता है उसको अच्छे से देखिए। और चैनल को सब्सक्राइब कर दीजिए जिससे कि आपको जो अपकमिंग जो भी हमारे वेबिनार्स हो रहे हैं उनके भी डिटेल्स आपको मिल जाएंगे। और मैं अभी ज़्यादा टाइम नहीं लेते हुए मैम को हैंड ओवर करती हूँ। मैम प्लीज।
Thank you, Priyanka ma'am. Good evening, student. Today we will be discussing the one mark question of chapter 3 of NCERT textbook. And first of all, I'd like to wish you all a very happy new year. So, but your exam dates, CBSE has announced the exam dates for class 10 and 12th board exams. And similarly for classes 9, the schools will be announcing their dates soon. So, revision is very must, and with these with the one mark platform you can revise all the short answer types question, one mark questions. So let's start this chapter 3 of NCERT textbook, atoms and molecules. We'll be first starting with the multiple choice questions. And your first question is, the law of definite proportion was given by, and your options are John Dalton, B is Humphrey Davy, C is Joseph L. Proust, and D is Michael Faraday. And you all know the answer, must be knowing the answer, that is Joseph L. Proust. Together, Joseph L. Proust and Antonio Lavoisier has given the laws of chemical combination. The second one, law of definite proportion in the laws of chemical combination, was given by Joseph L. Proust. Then the percentage of copper and oxygen in a sample of copper oxide obtained by different methods were found to be the same. This illustrates the law of, your options are A, the constant proportion, B, conservation of mass, C, multiple proportion, and D is reciprocal proportion. So your answer will be, if you obtain any compound from any source, then they will always have a constant proportion. This law was given by Joseph L. Proust. This is the law of constant proportion. Then a change in the physical state can be brought about. If you try to change the physical state of any matter, what you have to do is A. Only when energy is given to the system. B. Only when energy is taken out from the system. C. When energy is given out or taken out from the system. And D. Without any energy change. So, if we try to change the physical state of any matter, we'll have to either give the energy or take out the energy from the, and this can be very well explained with the help of simple example, that is water. When you heat the water, it changes into its vapor state. So then you are providing the heat energy. And when you are trying to cool it down, it will change again back to the liquid state. Next question is, a group of atoms chemically bonded together. So if you group atoms together and chemically bound them together, what do you form? A molecule, B ion, C salt, or D element. So if you group the atoms together, you will form a molecule. Okay, and molecule is the smallest part of an element which can exist independently, and it will show the characteristic of that particular element. Then next is the molecule having an atomicity of 4. So atomicity is the number of atoms which may be present in a molecule. So you have to tell which among the following is having the atomicity of 4. Your options are A. Sulfate molecule, B. Ozone molecule, C. Phosphorus molecule, or D. Methane molecule. And your answer will be C. Phosphorus molecule. Phosphorus molecule is actually the 4 atoms of phosphorus bound together. So it shows the atomicity of 4. Next is, adding electrons to an atom will result in a or an. So when atoms are neutral in state. Okay, there are positive and negative charges which are equal to each other in an atom which is neutral. Now, if you try to add an electron to the atom which is a negatively charged, okay, so what now will be this particle which is formed is the entity which is formed is called as an anion. It is a negatively charged atom because an additional electron is added, so it now acquires a negative charge. So your answer will be B, anion. Okay, a negatively charged ion, that is anion. Next, molecular mass is defined as A. Mass of an atom compared with the mass of one molecule. B. Mass of one atom compared with the mass of one atom of hydrogen. C. Mass of one molecule of any substance compared with the mass of one atom of carbon-12, or D. None of the above. So I hope you must be knowing this answer. That is, when the standard entity which was taken as universally accepted for measuring the other as a unit of measurement was that of carbon 12. So your answer will be C, that is mass of one molecule of any substance when it will be compared with the mass of one atom of carbon 12. Then next question. The formula of a chloride of a metal is MCl3. The formula of phosphate of metal M will be, so now here you have to consider the metal M. So M is here M is not symbol for any particular element, but it's general, like we take any variable. This is an alpha variable M which we have taken for metal, and suppose if it is forming a compound MCl3, that is, it is combining with chlorine to form a compound which has the formula of MCl3. Now you must know the some of the valencies, at least the valencies of first 20 elements. So if you know that chlorine has a valency of -1 And so here and when we are writing the chemical formula, we cross multiply the valencies to the elements. So here if chlorine is showing as 3, that means metal M is having the valency of 3. Now you have to calculate the formula for the phosphate of the same metal. So now you will be taking PO4 and M. So below M you will be writing valencies as 3, and below phosphate you will be writing as valency as, now you must know the valency of phosphate also over here, that is -3. And both the valencies will cut out each other, that is 3 and 3 will cancel out each other, and then we'll get the formula of the metal phosphate as MPO4. So the answer will be A over here, that is MPO4. So similarly, you may be given some other examples also. Here we have taken the formula of that metal chloride and that metal phosphate. Similarly, you may be asked about any other. Suppose a carbonate is given and you will have be asking about nitrate. So you must remember some of the valencies which are given in the table in your book. Polyatomic ions also here, and PO4 is a polyatomic ion. So some of the polyatomic ions are also given in your textbook. Their valencies are given. So PO4, you must remember that it has a valency of -3. Similarly, nitrate NO3 has a valency of -1. Carbonate has a valency of CO3 that is having a valency of -2. So you remember all these valency, then you will be able to take the formula. Next is, you have been given a molecule, the molecule formula P2O5. That means that a molecule contains 2 atoms of phosphorus and 5 atoms of oxygen. So here this formula is depicting is of phosphorus oxide. This is a oxide of phosphorus and with the formula of P2O5. So here what it is depicting, you have to tell. A, that is molecule contains 2 atoms of phosphorus and 5 atoms of oxygen. B, the ratio mass of P to the mass of O in the molecule is 2:5. B, C, there are twice as many phosphorus atoms in the molecule as there are in oxygen atoms. Or D, the ratio of mass of P to as of oxygen in the molecule is that of, I am sorry, here there is an error, to that of oxygen in the molecule is 5:2. Now I told you that whenever we are writing the chemical formula, we just cross multiply it. In the simpler form, you understand it that way, that we cross it. So now for phosphorus it must be 5 and for oxygen it must be 2. So the ratio, and then they have been cross multiplied to get the formula P2O5. So here the D option is the correct one. The ratio of the mass of phosphorus will be 5 to the ratio of oxygen will be 2. So answer is D. The ratio of mass of phosphorus to that of oxygen in the molecule is 5:2. There is a correction. Please correct it. To that. The S लिखा है. This is that of oxygen. Okay, next is the total number of atoms represented by the compound copper sulfate pentahydrate, that is CuSO4.5H2O. Sometimes you may be given the name of the compound, so you remember the formula of the compound. Here I have written the formula, and most of the time you may be given the formula, but even by names also you try to remember. So this is copper sulfate pentahydrate. So you have to count the total number of atoms present in this compound. So we'll have to tell, first of all, you have to know all the elements which are present in it. So first you have to sort that out. Copper, sulfur, oxygen, hydrogen, and then again oxygen. So you count copper 1 atom, sulfur 1 atom, oxygen 4 atom is there. So copper 1, sulfur 1, and oxygen 4, this 6.5H2. That means 5 multiplied by how many atoms are there in H2O. H is having 2 and oxygen 1. So this is 3 into 15. into 5, that is 15, and 15 plus 6, you will get 21 as the answer. So your answer will be 21. You just have to count the total number of atoms which are present over here. Okay. So this was the end of multiple choice question. Next we'll come to the one word answers. Okay. So the first question is, name the two scientists who proposed the laws of chemical combination. Out of that, we discussed about the first one, that is the second one, the law of constant proportion. The first one was law of conservation of mass. So law of conservation of mass plus law of constant proportion together constitute your laws of chemical combination, and they were both the laws were proposed, you can say, unitedly by two of the you can write their surname as well, Lavoisier and Proust. Next is the atomic radius is measured in nanometers. Express nanometers in the terms of meters. So you have to tell how much 1 nanometer will be equal to, if you have to tell it in the terms of meter. So 1 nanometer is, nano here depicts ninth time. So you have to divide 1 meter by 10 raised to the power 9. Okay, that will be 1 billion. 1 nanometer is equals to, you can write it in the terms of meter as 10 raised to the power minus 9 meter, or 1 divided by 10 raised to the power 9 meters. Okay, that is the value of 1 nanometer. Next is, name the smallest particle of an element or compound that can exist independently and show its properties. So you all know that atoms, they are not capable of existing independently. They either combine with the atoms of same kind or the atoms of other kind of element and form a molecule which can exist independently and show the all the properties of that particular element or that particular compound. Next is, write the atomicity of oxygen gas and ozone molecule. So you have to count the number of atoms which is present in the oxygen gas. By the formula itself, you can know that oxygen is having 2 atoms in it and ozone is having 3. So the atomicity of oxygen will be 2 and ozone will be 3. That is, 2 oxygen atoms will combine, then oxygen will be formed. And if 3 oxygen atoms will combine, then your ozone gas will be formed. Next, name the scientist who suggested the modern use of letters as the symbols of elements. So, Dalton first proposed the atomic theory, then he suggested some of the symbols for the for different types of atom, but they were not very clear, and they were not very easy to remember. So the scientists later on, they were not very much impressed by it, and scientist by the name of Berzelius, he suggested that we can use the first letter, or if two elements are by the same, starting with the same letter, then we can take at least 2 letters of those elements and form the symbol. If the second one is also common, then we take the third one as the second letter. Okay, like in the case of magnesium, we take M and G, not A. Okay, so this was proposed by Berzelius. He suggested the use of first first or first 2 letters of the element name as their symbols. Like, for example, I give you, for example, sodium. Its earlier name was natrium. So Na was taken as a symbol of sodium. Then potassium, its old name was kalium, and so K was taken as its symbol. Similarly, nitrogen, because nitrogen and sodium, that is natrium, they were both starting with N. So in the case of sodium, that is natrium, we took Na, nitrogen, N only was taken. Similarly, so on and so forth, we have different types of elements. The symbols are given by the first two or first letters. Then two elements X and Y combine to form a compound with the formula X2Y3. So here also your critical thinking is required. Two elements X and Y are given to you and they are forming a compound with the formula X2Y3. Write the valencies of X and Y. Can you guess the valencies of X and Y? Because how I have told you earlier also, you have to write the symbol of the element, and below that we write the valency of those elements and then we cross them. So the valency with Y is actually of the number with Y is actually depicting the valency of X, and the number with X is depicting the valency of Y. Sometimes they are taken in ratio also, but here, like in the case of carbon dioxide, CO2 is taken as a formula because there carbon is having valency 4 and oxygen is having valency 2, and we convert it into the simplest ratio, that is 2:1. But we know that the valency can be up till 4, usually up till 4 only, and so these 2 and 3 will be the specific valencies only, 2 of Y and 3 of X. So your answer will be X is having valency 3 and Y is having valency 2 because we have cross multiplied them when we are forming the formula. Then write the formula of aluminum oxide. Now again you have to know the symbols and then we have to know the valencies of this particular element. So for aluminum you will have to write the symbol is Al and oxygen O, capital O. Remember always, okay? Elements, their symbol must start with a capital letter, and the second, if there is a second letter, then it will be in the small. Okay? So here A will be capital, L will be small. AL, and O will be in capital because it is representing another element. It will be written with capital. Now aluminium, the valency of aluminium is 3 and that of oxygen you know is 2. So now you have to cross it, and aluminium will get as Al2 and O will become 3. So your formula which you will get is Al2O3. And remember that A will, for aluminium we will write A with capital but L with small, and for oxygen you will write O as capital letter. Okay, sometimes children write it with small letter, that becomes wrong. First letter, if the element is representing only by one letter, it will always be capital only. If there is a second letter as well, as in the case of aluminum you are seeing, that will be written by a small letter. Okay, next, name the elements that combine to form water. So water is the most common one which we use, compound which we keep talking about in our day-to-day life. All of you must know the elements which combine together to form water, and most of you must be knowing. We know the formula, that is H2O. So hydrogen and oxygen are combining to form water. These are the two elements which combine to form water. Based on the same question, I have discussed only one examples for each. You may be given other other related questions as well. So I am just telling you by one examples how to do all this. So you have to calculate the relative molecular mass of water. Now you first know the formula for water, that is H2O. Then you must know the atomic mass of each of the elements which are present over here. So hydrogen is having one unit as atomic mass and oxygen ki 16 units. And now you check the formula H2O, that means two hydrogen atoms. So you have to multiply 1 by 2 because two hydrogen. Okay, so 1 into 2 will become 2, and then oxygen, only one oxygen. When we have only one atom of that element a compound, then we don't usually write any number in front of it. That means it is depicting only one atom of that. So oxygen only one atom, so we have to add them. 2 plus 16 and it will become 18 unit. Similarly, for any other element, any other compound, uh, so you have to calculate in the same way the relative molecular mass, or maybe similarly you have formula unit mass also. If the formula of any compound is given to you, the numeric value which you get is always the same. Just in the case of molecule, we write it as molecular formula, or if there is a formula for any substance, then we take it as a formula unit mass. Next is find the ratio of hydrogen and oxygen in water. Now, this question sometimes confuses children. This is, see, you have to be clear that you have to tell the ratio of hydrogen and oxygen in water first by the number of atoms and second by their atomic masses. Sometimes children get confused and interconvert them. Okay, instead of writing number by atom, they write atom by their atomic mass, ratio by atomic mass. So these two are different. When you are taking by number of atoms, the formula is H2O. That is, two hydrogen is combining with one oxygen. So the ratio will be 2 is to 1. By the number of atoms, if we count, the ratio of hydrogen is to oxygen will be 2 is to 1. If we calculate it by atomic mass, now atomic mass, you must remember hydrogen 1 and oxygen is 60. So because the formula of hydrogen is, water is H2O, hydrogen, we have to take 2:16. And then when we convert it into simpler form, we will get 1:8. So when you take the ratio by number of atom, it will be 2 is to 1. And when you will take the ratio of hydrogen is to oxygen, by their atomic mass, it will be 1 is to 8. So remember this, sometimes children get confused between the two of them. Okay, so we come to the end of one more question. I have given one example for molecular mass and one example to find out the ratio by number of atoms or by atomic mass. You can do it with different examples. We come to the assertion and reasoning question. This is something which has been newly introduced by CBSE, but children, now because we have done so many sessions, you must be familiar with it now, but still I will discuss the instruction for those who are watching it for the first time. Instructions are given like, you will be given two statements, one for the assertion and one for the reason. You have to tell that if the statement of assertion and reason are both are true, first you have to check that both the statements are true, and then you have to check the reason which is given over there is explaining the assertion properly or not. So by making all these conclusions, you have to mark as 1 if both assertion and reason are true and reason is the correct explanation of assertion. You have to mark 2 if both assertion and reason are true, but reason is not correctly explaining the assertion. You have to mark 3 if assertion is true, but reason is false. You have to mark 4 if reason is true, but assertion is false. And 5 if both assertion and reason are false. So first you read the instruction properly. Sometimes these instructions may change. Sometimes ABCD is given instead of 1, 2, 3, 4. ABCD may be given, and sometimes this fifth option may not be there. So you have to read the instructions properly, and then you come to the question. So your assertion is first assertion is one atomic mass unit AMU, which is now earlier it was called as AMU. Now it is actually written as U only. Okay. So 1 atomic mass unit is the mass of an atom equal to exactly 1/12th mass of the carbon 12 atom. And the statement for assertion is correct. Reason: in 1961, carbon-12 isotope was selected as the universally accepted standard reference. So this is also true. And this reason is actually explaining the assertion. क्योंकि carbon-12 isotope से ही हम compare करते हैं. So this is and this was universally accepted also for standard reference. So both assertion and reason are true. You will mark it as 1. Okay, see in the answer I have written 1. 1, that means both assertion and reason are true and reason is the correct explanation of assertion. Then next is assertion is that the molecular mass and formula unit mass of a substance is the sum of atomic masses of all the atoms in the molecular formula or the formula unit of a compound. So this assertion is true. Okay, and just now only we discussed कि हमें कभी molecular mass, when we have to calculate the molecular mass, we have to sum all the atomic masses which are present in that particular molecule, or if it is a molecule in molecular formula, or if it is a compound, then we take it as a formula unit. So reason given is that the only difference between the molecular mass and formula unit mass is that the former is for the molecular compounds, that is covalent compound, and latter is for the ionic compound. However, their numeric value is same. So this is also true. This reason is also true. But is it explaining the assertion? No, it is not explaining the assertion. Okay. So here we will mark the answer as 2. That is, both assertion and reason are true, but reason is not the correct explanation of assertion. Okay. Then the third question is for assertion we have a molecule is the smallest particle of an element or a compound which is capable of free existence. So assertion is correct. A molecule is the smallest particle of an element or a compound which is capable of free existence. This is true. Reason given is the number of molecules present in the substance is called as atomicity. The reason is the statement for the reason itself is wrong. So you will write assertion is true, but the reason is false. Reason statement is false. Okay. When the reason statement is correct, then you mark it as, if the reason is not explaining, but it is correct, then you mark as true. The statement for the reason is true, but it is not explaining, then you mark 2. But if the statement for the reason itself is wrong, then you mark it as 3. That is, assertion is true, but reason is false. Here, we will mark 3. Okay, next is assertion is given is law of conservation of mass holds good for nuclear reaction. And this is the exceptional case where law of conservation of mass does not hold true for nuclear reaction, because these are because of the change in the atomic masses keeps on going. The nuclear reactions are that way. So the law of conservation of mass do not hold for nuclear reaction. So assertion is wrong. The statement of reason, let's see. It states that energy can neither be created nor can be destroyed in a chemical reaction. So whenever law of conservation of mass is followed, then this statement is reason statement is true, that energy can neither be created nor can be destroyed during a chemical reaction. But for nuclear reaction, this is an exceptional case where the law of conservation of mass is not followed. So here we'll mark as 4, which says that reason is true, but assertion, the statement for assertion is false. Okay, next come assertion. The atomicity of ozone is 2. Reason is the number of oxygen atom present in one molecule of ozone is 2. Now here both of the statements are wrong. Atomicity of ozone is 3 because 3 oxygen atoms combine to form ozone. The 2 atomicity is of that of oxygen gas. 2 atoms of oxygen combine to form oxygen, not ozone. Or in the case of ozone, it is 3. So both the statements are wrong. We will mark as 5. Both assertion and reason are false. Next, atomic mass of aluminium is 27. assertion is correct. Atomic mass of aluminium is 27, if you remember. Reason is an atom of aluminium is 27 times heavier than 1/12 of the mass of carbon 12 atom. So obviously when we compare, because in previous slides we have already discussed, we compare the atom to the size of 1/12 mass of carbon atom. Okay, and so because aluminium is 27 times heavier, that is why the atomic mass of aluminium is 27. So here you will mark as 1 assertion. Both assertion and reason are true, and reason is the correct explanation of assertion. Next is assertion. 1 mole of molecule has mass equal to the gram molecular mass and contains Avogadro number of molecules. So this is also known as mole concept. 1 mole of any molecule has a mass equal to the gram molecule. You will convert you will first calculate the molecular mass, and instead of writing U, you can write it G in the case of gram molecular mass, and it will also contain the Avogadro number. You must know the value of Avogadro number, which is a question in the coming slide, so I am not telling you over here. Avogadro number of molecules. So this is called as mole concept also. Okay, so this statement is true. The reason is that 1 mole of an ionic compound has mass equal to the gram formula unit and contains Avogadro number of formula unit. So this reason statement is for ionic compound, and it holds true for ionic compound. So the statement for the reason is true, but it is not actually explaining the assertion. So you will mark the statement as true. That is, both assertion and reason are true, but reason is not the correct explanation of assertion. Next assertion given is, in ionic compounds, the charge on each ion is used to determine the chemical formula of the compound. Okay, so in ionic compound, the charge on each ion is used to determine the chemical formula. This is correct statement. That is how we find out the chemical formula of ionic compounds. The reason given is that ionic compounds are formed by the combining of two ions. Okay, so ionic compounds are formed by the combining of a cation and an anion, which is generally a metal and a non-metal. So here the reason is wrong. You will mark the statement for the reason itself is wrong. The two ions, out of the two ions, one ion will be anion and one will be cation. That is how ionic compounds are formed. One cation and one anion combine, or maybe two cation depending on their valencies. Okay, so ionic compounds are formed by combining of anion and cation. So reason is false. The statement for the reason is false, and the statement for assertion is true. So you mark as 3. Next, assertion. Water obtained from different source will contain hydrogen and oxygen combined in varying ratio. So statement. Okay, well, first we'll see the reason. A chemical compound always contains same element compound combined in the same fixed proportion by mass. Okay, this is the law of constant proportion, which says that even if you form a chemical compound by any process, it will always have the same formula. That is, it will always combine in a fixed proportion, and the elements will combine in the fixed proportion by their masses. So the assertion statement is wrong. The reason statement is correct, but the assertion statement is wrong. Water, when we obtain water from any of the source, you obtain it from lake, river, well, anywhere, the formula for water will always be H2O. That is, their ratio will always be in the 2:1. If you sorry, by mass, if you will take, it will be 1:8. But so by mass, it will always be 1:8. And therefore, here you will mark as 4. That is, reason is true, but assertion is false. Okay, next is assertion given is molecular weight of carbon dioxide is double to that of the oxygen. Okay, here Here, the assertion is wrong because molecular weight of carbon dioxide is not double of that of oxygen. Okay, and the reason, 1 mole of carbon dioxide contains double the number of molecules present in 1 mole of oxygen. So this is also wrong because 1 mole of any of the gases which you will take or any molecules which you will take, it will always have the same number of molecule, that is known as Avogadro constant. So both the statements are wrong and you will mark it as 5. Both assertion and reason are false. With this, we come to the end of assertion and reasoning type question. I hope you all got it. There will be not many questions from assertion and reason, but whatever will be there, 4 or 5 will be there. They will be very solid, and if you are not able to do, you may lose. So try to read the statements very carefully and instructions as well. Whatever the instructions are given, according to that, you have to mark it as 1, 2, 3, 4, or if there is a fifth one also, so 1, 2, 3, 4, 5, or A, B, C, D, E, whatever is given. So what if? But first read the statements very carefully and then try and answer. Next, we'll come to the fill in the blanks. All of you are very familiar with these types of questions. So first is, during a chemical reaction, the sum of the dash of the reactant and product remains same. So what is it? The sum of the masses of the reactants and products always remain the same. This is called as law of conservation of mass, and this is the first law of chemical combination. Okay, that was given by Anton Lavoisier. Next is, in a pure chemical compound, elements are always present in a dash proportion by mass. And this is the second law which was given by Joseph L. Proust, that is law of constant proportion, that says that where if you have a pure chemical compound, the elements will always be present in definite proportion by their mass. That is, if you, for example, if you take water, water will always have 1:8 ratio of their mass. Wherever you will find water, it will always have the ratio 1:8 by their mass, by the mass. Okay, elements by their mass. So by the mass, hydrogen is to oxygen, it will always be 1:8. And I told you in the, I think in the 1 mark question, last question was, by mass how will you calculate, and by number of atoms how will you calculate. By number of atom it will be 2:1, and by mass it will be 1:8 in case of water. Next is, when an atom loses electron, it is called a dash and has a dash charge. So now you have to tell. I have in one of the slides, I don't remember, it was, I think, multiple choice. You had, when an atom gains an electron, it was called as an anion. So where now the question is, when an atom loses an electron, it is called a anion and has a positive charge. So here, when an atom loses its electron, it is called an anion and has a positive charge. Okay. Next, the cluster of atoms that act as ions are called dash ions. Cluster of atoms, when they come together, and they are actually also acting as ions only, so they are called as polyatomic ions. Okay, there are many ions combining together and forming one unit of ions. So for example, carbonate ion, in here carbon and oxygen ions, and has a total charge of -1 and -2 in the case of carbonate. In the case of nitrate, nitrogen and oxygen ions are there and they have a total charge of -1. Similarly, for phosphate, I've told you, phosphorus and oxygen ions are combined together and they have a total charge of -3. So these are some of the examples of polyatomic ions. Then the combining power or a capacity of an element is known as its combining power of of an element. It is called as the valency, how much electron it can lose or it can gain. That is the called as valency, and that is the combining capacity, because this is how we write the molecular formula, how it will combine with any other element to form a compound. So this is called as valency. Next, the valency of an ion is equal to the, sorry, I have read the answer only. The valency of an ion is dash to the charge on the ion. So whatever the charge is on the ion, that will be equal to the valency. How much electron if it is losing an electron, or if it is gaining an electrons. That is the number of valency which will be there. Okay, for example, like chlorine, it will have -1 valency because it is gaining one electron. And for example, sodium, it is losing one electron, and therefore the valency is +1. Then next, the charge on each ion is used to determine the dash of the ionic compound. So if you know the charge of the ion, in an ionic compound, you can tell the formula, chemical formula of that ionic compound. Like just before I told you, sodium, it loses one electron, and therefore it has a valency of +1, and chlorine, it gains one electron and therefore has a valency of -1. And when we both of them combine, therefore we get the formula of NaCl. So we get the formula NaCl because of that. But if we have to calculate for calcium, similarly the chloride of calcium, if we have to calculate, so chlorine will have the formula, chlorine will lose one electron only. Gain one electron only, but calcium will lose two electrons. So to take these two electrons, two chlorine will combine with calcium, and therefore we'll have the formula as CaCl2. In the case of sodium, it was NaCl only, but in the case of calcium chloride, we'll have CaCl2 because of this, their combining capacity. Okay, and if you know the charge on each of the ion, you can write the chemical formula easily. Next, the molecular mass of a substance is sum of dash of all atom in a molecules of the substance. तो जैसे हमने पहले किया ही है 1 मार्क के क्वेश्चन में, I think the molecular mass, if you have to calculate, you have to sum all the atomic masses of all the atoms. अगर हमको सारे atoms के atomic masses पता है, तो we can calculate the molecular mass. The next is mass of 1 mole of a substance is called as its. अगर हम 1 mole of substance लेते हैं, तो वो जो कि हम मोल कॉन्सेप्ट में बोलते हैं, तो उसको हम मोलर मास बोलते हैं. Okay, next is the value of Avogadro constant. So I didn't tell you the Avogadro constant value because here we had this, and this is 6.022 into 10 raised to the power 23. That is the number of molecules that will be present in 1 mole of any molecule, or the number of atoms present in 1 atom of any element. So this is called as mole concept, and it is defined as a number of atoms exactly in the 12 gram of carbon 12. Okay, तो हमने इसको, because carbon 12 was taken as the standard comparing unit, so this will be exactly equal to the 12 gram of carbon 12. Okay. So with this, we come to the end of fill in the blanks, and next we will be coming to true and false. That is the last segment of our division. The first statement is, in a pure chemical compound, elements are always present in definite proportion by mass. So this is true because it is one of the law of chemical combination. Second law of constant proportion. This is a true statement. Second, the building block of all matters are atoms. Yes, these are the smallest unit of matters. Okay. So according to Dalton's theory, he said that atoms cannot be further divided into smaller But later on, we had subatomic particles, but those are you can say those are subatomic particles. But the building block of all matter will be considered as atoms. So this is a true statement. Next, mass of 1 mole of a substance is called is formula mass. This is wrong. Mass of 1 mole of a substance is called as molar mass, not formula mass. This is false. Then next is those particles which have more or less electron than the normal atoms are called ions. So this is a true statement. When an atom loses electron or when an atom gains an electron, they turn into ions. Okay. When it is a positive ion, it is called as anion, and when it is a negative ion, it is called as a cation. Negative ion means it is gaining an electron, and positive ions mean it is losing an electron. Because electron carry a negative charge. So when an atom loses electron, it becomes positively charged. And when an atom gains an electron, it actually becomes negatively charged because there is one extra negative charge over it. Next, formula for sulfur dioxide is SO3. Now here, by the name itself, dioxide, that means two oxygen will be there. So this is wrong. Sulfur trioxide, actually, this is the formula for sulfur trioxide, not dioxide. For dioxide, it is SO2. So this is false. Cluster of atoms that act as an ion is called as polyatomic ion. This is true. We have already discussed that cluster of atoms act as, if they act together, then they are called as polyatomic ion. The combining power of an element is known as its atomicity. This is wrong because combining power of element is its valency, not atomicity. Atomicity is the number of atoms which may be present in a molecule of an element. Okay, so you can correct the statement by changing the definition. That is, the number of atoms present in the molecule of an element is called as atomicity, or you can change by changing the name of combining power of an element is known as its valency. Okay, so this statement is false statement. Then next is the abbreviation used for lengthy names of element are termed as their symbol. So this is true because we use for lengthy name, instead of using the lengthy name of elements, we are using their abbreviations. Okay, for calcium Ca, for carbon C, for copper Cu. So these are the abbreviations of the elements. Instead of writing copper, we just write Cu. If we are writing C, that means capital C, that is denoting carbon. If we are writing capital C small a, that is calcium. So these are the symbols or abbreviation used for elements. Okay, 1 mole of any substance is fixed with the value of 6.022 into 10 raised to the power minus 23. So here it is wrong because 1 mole of any substance is 6.022 into 10 raised to the power 23, not minus 23. So read the statement carefully. This is false. Sometimes we just hurry up. In the hurry, we see the number and we just mark it as true. But remember that the power is given in negative over here. So this is wrong. Mole is a link between the mass of atom and the number of atom. This is a true statement because we actually connect the molar mass and the Avogadro constant as the number of atom present in that 1 mole. Okay, so this is true. So with this, we come to the end of our slides. I hope you all this clears your at least 1 mark questions. All the 1 mark questions. All the best, children.
Thank you so much, ma'am, for sparing your valuable time and sharing this very
All
useful
my
knowledge
sessions.
with our viewers. And hope कि आप आगे भी और भी सेशंस कंडक्ट करें 9th क्लास के लिए मैम आई थिंक एक स्टूडेंट को कुछ डाउट था। आई थिंक पता नहीं क्लियर हुआ है। अगर आपको बेटा डाउट है कुछ फराद्दीन अहमद, आपको डाउट है तो आप कमेंट बॉक्स में डाल सकते हैं। मैम आपके क्वेरीज को सॉल्व करने की ट्राई करेंगे। और
Okay,
आई
I
हैव
can't. I
कमिंग
can't see over here. You can give me the comment, and later on I'll clear it out to you because I can't see right now.
and I have shared in live comment box, I have shared feedback form also। आप उसको अगर फिल करेंगे तो आपको अटेंडेंस सर्टिफिकेट भी आपको इशू हो जाएगा आपके मेल आईडी पे। तो आप उसको फिल कर दीजिए। नहीं, अभी कोई डाउट नहीं है साहिल साहब के, नो डाउट। ओके मैम, थैंक यू सो मच मैम, थैंक यू,
Okay, it was my pleasure. All the best, children. Do your revision well.
थैंक यू सो मच।
Good evening.